This is the Pre-Calc Unit 3, Lesson 2, Simplifying Trig Expressions. We're going to use the fundamental trig identities in order to simplify expressions. But before we get into using trig identities to simplify these expressions, I want to go over a review of some Algebra 2 skills, and some of these even date back to Algebra 1. If you are fairly confident that you know these skills and you have done all these problems and don't need me talking through, feel free to fast forward. But here we go. First of all, you'll need to be able to multiply expressions. So for example, if you have a monomial outside of parentheses and a polynomial inside the parentheses, and monomial, by the way, means that you have just one term, so the 3x would be your monomial. And terms are separated by a plus or minus sign, so inside the parentheses you've got 3 terms. And what you'll do then is take that monomial outside and multiply it separately times each of the terms inside of the parentheses. And so what you get in this problem then is first 6x to the 4th power, and then minus 15xy, and then plus 12x. In part B, the way I do these problems is a method called FOIL, which means firsts, outsides, insides, lasts. And the firsts means the first term of each binomial. And so first times first, x times x is x squared. Then outsides stands for the terms on the outside of the problem. And so that's x times 7. And x times 7 is positive 7x. And then I stands for insides, and insides means the terms on the inside of the problem, and that's the negative 3 and the x. So that's going to be minus 3x. And then the word lasts stands for the last term of each binomial. So the negative 3 and the positive 7. Negative 3 times positive 7 is negative 21. And typically with problems where you're multiplying a binomial times a binomial and you use FOIL, you're going to end up needing to simplify the middle 2 terms, which will be like terms. Not always, but often. And so the answer to this problem is x squared plus 4x minus 21. And that's when you're multiplying a binomial times a binomial. Now if I use FOIL to multiply x plus 3 times x minus 3, my firsts gives me x squared, my outsides gives me minus 3x, my insides gives me plus 3x, and my lasts gives me negative 9. And when I combine those two middle terms, notice that negative 3x and plus 3x are going to cancel each other out, and all I have left is x squared minus 9. Now, when you factor, you're basically doing the opposite of the multiplying. You're looking for two polynomials, or a monomial and a polynomial, that would multiply to give you this expression as the answer. So, for example, x squared minus 4 is pretty much the reverse of the problem that we gave you in letter C. Notice that you have two perfect squares, and they're separated by a minus sign. So you've got a 2-term polynomial, perfect squares for both terms, and they're both separated by a minus sign. And so your answer is going to be x plus 2 times x minus 2. In letter E, we have the same type of factoring. Notice that 4 is a perfect square, x squared is a perfect square, and 1 is a perfect square. So it's a two-term polynomial with everything as a perfect square separated by subtraction. And so you're going to take the square roots of everything and add and subtract. Now in the next problem, you'll see that you have a common factor. Both terms of this expression have an x in them. And so you want to factor out a GCF before you do any other type of factoring. So now I have x on the outside times parentheses 9x squared minus 16. And again, you'll see that you have perfect square. The 9 is a perfect square, and the x squared is a perfect square, and the 16 is a perfect square, and you have two terms that are separated by a minus. Now you have to keep that GCF, the x that you took out in the first step, and then the square roots of everything added and then subtracted. So 3x plus 4 times 3x minus 4. Now in letter G, you've got a quadratic trinomial. Trinomial means that you have three terms, and quadratic means that the first term has an x squared, the next term has x to the first power, and the last term is just a constant, or a number that doesn't have a variable. When you do this type of problem, you look at the last number, and that's the answer to a multiplication problem, and then look at the middle coefficient, and that's the answer to an addition problem. You want to find two numbers that both multiply to positive 6 and add up to negative 5. And those two numbers in this case are negative 2 and negative 3. The thinking here is that negative 2 times negative 3 is positive 6, and negative 2 plus negative 3 is negative 5. And so your answer is going to be x minus 2 and x minus 3. And if you want, just to be sure, you can FOIL to check your answer. Now, another skill that you'll need in order to simplify trig expressions is being able to simplify polynomial expressions that have fractions, or what we call rational expressions. And the first thing that you need to remember is that if everything is being multiplied, you can cancel from any numerator to any denominator. So I'll start by noticing that I have a factor here that's x minus 2 and a factor here that's x minus 2. And so I can cancel those two terms. The other thing that I notice is that I have a 4 here and I have a 2 here, and I can cancel 2 divides into 4 2 times. Notice that I have canceled all my denominators, leaving me just 1, and we don't write 1 as a denominator, so our answer is going to be without denominator. The other thing that I want you to notice is that you have an x minus 3 here in the numerator and an x minus 3 here in a numerator, and you cannot cancel a numerator with a numerator. And so we're going to keep that 2, and then we're going to multiply x minus 3 times x minus 3, but we're going to call that x minus 3 squared. And so after you're all done with your canceling, you've got 2 times the quantity x minus 3 squared. In letter J, what you want to do first is factor both the numerator and denominator. So when I factor the numerator, I get x minus 6 and x plus 1. And you might want to pause the video for a second and make sure you understand why the answer to this numerator factored is different than the answer to problem 2G when you factored a similar quadratic trinomial. One of the signs is different, and that changes what the factors are going to be. So make sure that you see that difference. When I factor the denominator x squared minus 1, I get x plus 1 and x minus 1. And again, I can cancel from the numerator to the denominator. And so my final answer for this problem is going to be x minus 6 over x minus 1. Now, this problem in K, it's pretty ugly. I'll just tell you that right up front. At the end of the problem, nothing's going to cancel or simplify, but just make sure that you understand how common denominators work. So when I look at the denominator in the first fraction, I have 6x, and the denominator in the second fraction is y squared. And to make those two fractions have the same denominator, I need to multiply the first by y squared over y squared, and I have to multiply the second by 6x over 6x. So then what I get, and it would help you to write out this step first and then do your distributive property. These tend to be a little bit tricky. Try not to do that in your head. But you get y squared times 5x plus 3 minus 6x times 4x minus 1 all over 6xy squared, which is the common denominator. Now you can do the distributive property, and you end up with 5xy squared plus 3y squared minus 24x squared plus 6x all over 6xy squared. Before you move ahead, make sure that you understand why there is a plus with the 6x. This plus at the end of the numerator is the one mistake that if somebody's going to make a mistake on this problem, it will be with that last term. Nothing cancels, nothing simplifies, nothing factors, and so I'm just going to leave that problem as is. Now, on to the trig expressions. One of the skills that you'll need to be able to practice when you're simplifying trig expressions is rewriting anything in an expression in terms of sine and cosine. And if you think back to Unit 1, when we were computing the values of the quadrantal angles for the different trig functions, we talked about if you know all the ones and zeros for sine and cosine going around the unit circle at the quadrantal angles, you could use those values, the ones and zeros, to compute the values of tangent, cotangent, secant, and cosecant. And so it might help you in this case to remember that the tangent of x is always equal to sine of x over cosine of x. That cotangent of x equals cosine of x over sine of x. That cosecant of x is equal to 1 over sine of x. And that secant of x is equal to 1 over cosine of x. Now I'm guessing that you already have those 4 things memorized, and those are the things that we're going to be using a lot to simplify expressions. So just kind of keep those 4 identities in the back of your mind, and we'll keep calling on them as we work through these problems. So let's practice writing expressions in terms of sine and cosine. So for example, if I ask you to write this expression in terms of sine and cosine, one of the 2 things being multiplied is already sine, so we don't need to change that. But we do have one of the things being multiplied as cotangent, and so we want to change cotangent to any form of sine and cosine. Well, cotangent is equal to cosine of x over sine of x. And now I'm going to write sine of x from the second thing being multiplied above as sine of x over 1 to stress the fact that I know that I can cancel the sine of x. And make sure that you understand that although you're left with cosine of x over 1, that we really don't ever write the over 1 part. We're just going to say that the answer to this is cosine of x. Now in part B, I don't need to do anything yet to change the last factor here that is already sine of x, but I'm going to rewrite secant and cotangent, and I'll start with secant of x, and secant of x is 1 over cosine of x. And then cotangent of x that we just talked about in the previous problem is cosine of x over sine of x. And I'll rewrite this sine of x as sine of x over 1. Notice here that I can cancel that cosine with that cosine, and I can cancel that sine with that sine. And when I do all of that, I just have 1 over 1, and so my answer to this problem is just 1. Now, letter C is going to start by giving you a pretty significant looking fraction, but it shouldn't be that scary. First of all, tangent of x is, or can be written as sine of x over cosine of x. And then secant of x can be written as 1 over cosine of x. Now, at this point, I'm going to work this problem out twice and show you that you can get the same answer. First of all, if you don't mind taking a few more steps, we're going to write out the division. Just make this a little bit smaller. We're going to write out the division here, and you know that when you divide fractions, sine x divided by, or over cosine of x divided by 1 over cosine of x, that you change that to a multiplication problem. So that becomes sine of x over cosine of x times, but then you flip the second fraction. So that's going to be cosine of x over 1. We can cancel the 2 cosines, and our final answer is going to be just sine of x. Now, like I said, I'm going to do this problem twice, because what I want to show you is that if you have a fraction like this, that's a fraction over a fraction, and I just copied that same fraction. If you have a fraction over a fraction, and you see that the denominators of both fractions are the same, they will cancel. For the reasons that you see above, if you worked out the whole problem, but in this case then, you're just left with sine of x over 1, which is just sine of x. Now, I don't care if you want to write out all of the steps like this, or if you notice the cosines will cancel, then you're welcome to cancel them and go directly to sine of x. Now, I'm going to point out, starting at letter D and moving through the rest of this packet, that if you have larger handwriting, you might want to use separate paper because some of these problems require a lot of steps, and I didn't give you a whole lot of space for those of you who have larger handwriting. So you might want to pause the video at this point and grab a sheet of paper just to work out some of these problems. And problem D here is where you start to get into a problem that might have a few more steps. So in this problem, I'm asked to change cotangent over tangent in terms of just sine and cosine. And remember that cotangent is cosine over sine, and tangent is sine over cosine. And if you take those two fractions and divide them, you end up with cos of A over sine of A divided by sine of A over cosine of A. And if you don't want to show that particular step because you see that that's going to just become a multiplication problem, you're welcome to go immediately to the multiplication problem where you flip the second fraction. And so you can write cosine of A over sine of A times cosine of A over sine of A. And that gives you cosine squared of A over sine squared of A. So those are 4 examples of writing an expression in terms of just sine and cosine. But none of the, well, one of those expressions isn't what we would call completely simplified. And so what we're going to get into next is simplifying trig expressions. There are several methods that you'll use, and I'll walk you through some examples of the different methods. One of them is to start by changing things to sine and cosine. That won't be what you do in every single problem when you're asked to simplify, but some of the problems start out nicely like that. Keep in mind that when we're simplifying expressions, we want to have an expression that does not have parentheses, does not have denominators, and most often, but not always, will only have one term, which means you won't have plus or minus signs. Okay, that's not always the case, but most often. So the first type of problem that we're going to look at is a problem that you simplify by using the Pythagorean identities. So I want you to grab your formula sheet. That's that pink piece of paper that I gave you at the beginning of this unit. And the very top section is the section that says Pythagorean identities. That's the sine squared plus cosine squared equals 1, or tangent squared plus 1 equals secant squared, or cotangent squared plus 1 equals cosecant squared. Those are your Pythagorean identities, and those are the problems that you're going, or those are the identities that you're going to use to simplify each of these four expressions here in number 5. And so the first thing that you want to do is look for the identity that has secant in it. And that identity, you don't have to write this part, but that identity, here's what you're thinking. That identity is tangent squared x plus 1 equals secant squared of x. And if you rearrange this and make it a subtraction problem by subtracting 1 from both sides, you end up with tangent squared is equal to secant squared of x minus 1. Now, if an equation means that both sides of this equation mean the same thing, then tangent squared of x means exactly the same thing as secant squared of x minus 1. Therefore, I can simply replace secant squared of x minus 1 with tangent squared of x. And that's it, you're done. You've got one term, no parentheses, no denominators. That is now simplified. In the second problem, you want to look at the Pythagorean identity here, cosecant squared of x minus 1. And similarly, similar to problem A, we can just replace cosecant squared of x minus 1 with cotangent squared of x. Bring down your sine squared of x. Now, although there's no parentheses or denominators or plus or minus in this problem, I notice that I know that cotangent is cosine over sine and that the sines will cancel. So I'm going to take this problem another step, and I'm going to multiply sine squared of x over 1 times, and I'm going to change the cotangent to cosine squared of x over sine squared of x, and then cancel the sine squareds of x, and my answer is cosine squared of x. So in problem C, you might notice that there is nothing here that looks like one of the Pythagorean identities. All the identities deal with a trig function squared, and all of the identities have a 1 somewhere, and we don't have that anywhere here. But when I see this problem, the first thing I notice is that I've got a minus sign, and I want to see if I can rewrite this as an expression with one term rather than 2 terms. And if I can't think of any other way to start a problem, it's sometimes a good idea to practice changing everything to sine and cosine. So I'm going to rewrite secant of x here as 1 over cosine of x. I'm going to write tangent of x here as sine over cosine of x. And multiply by sine of x over 1. Notice that nothing cancels. But really here, I have 1 over cosine of x minus sine squared of x over cosine of x. And when I subtract my fractions, I end up with 1 minus sine squared of x over cosine of x. And at this point now, my numerator is one of the Pythagorean identities. Sine squared of x plus cosine squared of x equals 1. If I subtract sine squared of x from both sides of that expression, then I end up with cosine squared of x. And so here now I have the fraction cosine squared of x over cosine of x. And I can cancel one of the cosines in the top with the denominator that's cosine. And I'm left with just cosine of x over 1. And so my answer is just cosine of x. And in this last problem, I notice that I have one of the Pythagorean identities, and although the addition is reversed from how you're given the identity on your formula sheet, 1 plus tangent squared of x and tangent squared plus 1 of x, tangent squared of x plus 1 are both the same thing, and they both equal secant squared of x. So now I have secant squared of x over cosecant squared of x. Now, I need to find a way to get rid of my denominator. I'm not sure how to do that, so maybe I'll try changing everything to sine and cosine. And secant is 1 over cosine, so secant squared is 1 over cosine squared. Cosecant is sine, 1 over sine, and so cosecant squared is 1 over sine squared. And I can change that division to a multiplication. And so I have 1 over cosine squared times sine squared of x over 1. And that whole thing is equal to sine squared of x over cosine squared of x. And all of that is equal to tangent squared of x. Another method that you can use to simplify a trig expression is by factoring a polynomial trig expression. So let's look at some of the different types of factoring that we learned. And I'll start with a problem that has a GCF. Now notice the way this problem is given to you, you have 2 terms. The first term is cosine of x. The second term is all of this cosine of x times sine x squared. Remember that terms in algebra are separated by a plus or a minus sign. So you've got 1, 2 terms. Both of those terms happen to have cosine of x. And so I'm going to factor out a GCF, or a greatest common factor, and my GCF is cosine of x. So I'm going to factor out cosine of x. And when I divide cosine of x divided by cosine of x, that's 1. And when I divide this whole second term, when I divide that by cosine of x, The cosines cancel, but I'm left with sine squared of x. Now that I have divided out my GCF, I see here inside the parentheses that that's one of my Pythagorean identities. And that leaves me with cosine of x, which was my original GCF, times cosine squared of x, which is what I get when I substitute for my Pythagorean identity. Cosine of x times cosine squared of x will give me cosine to the third power of x. So that's factoring using a GCF, or factoring out a GCF. Let's look at problem B. This is a good place to stop and remind you that a lot of these problems can be done more than one way and get the correct answer. You want to get from point A to point B, and there might be 3 paths that you take to get there. I might be working the path one way, and you might be taking a different path, and that does not mean that you're wrong. So the way I'm going to start this problem, rather than immediately taking out the GCF that is cosine, I'm going to try to cancel some things, and so I'm going to change that tangent to sine over cos. So I'm going to rewrite this first term as cosine of x over 1 times sine of x over cosine of x. So I just changed the tangent to give me sine of x over cosine of x, minus, and then I'm just going to write the second term as it's given, sine of x times cosine squared of x. And in this way, I can cancel those cosines, and that first term is just sine of x. Now I see that I have another GCF. That is sine of x. So I'm going to factor out sine of x. That leaves me with 1 minus cosine squared of x. 1 minus cosine squared of x is sine squared of x. So I have sine of x times sine squared of x. And my answer is sine cubed. Now, in this next problem, I want you to specifically notice the numerator. And here's what I want you to think. If I change or think about the sine of x as some other letter, so let's say that I'm thinking about that sine of x. I'll replace it with the letter a, for example. That would be a squared plus 4a plus 3. Compare the numerator of the fraction to the quadratic expression that I just wrote with the a's in it. Now, the directions here say to solve by or simplify by factoring. Therefore, this must be factorable. 3 times 1 is 3. 3 plus 1 is 4. And so that factors to a plus 1 times a plus 3. And the a's, remember, I had used to replace sine. And so to actually factor the numerator here, I'm going to rewrite the numerator as sine of x plus 3 times sine of x plus 1. instead of a plus 3 and a plus 1. The denominator is sine of x plus 1. And now you can see that we can cancel the denominator with the 1 factor in the numerator. And my final answer is sine of x plus 3. And yes, this has 2 terms to it, but it can't be simplified any farther. And so we're going to just stop there. Now, this next problem has a little bit of a twist to it. And the first thing that I'll point out is that there's nothing here that can be factored. And I put this problem in the factoring section. Therefore, at some point during this problem, you're going to need to be able to factor something. Now, I can't change anything to sine and cos because everything's already sine and cosine. But the other skill that I have that I learned on the previous page is that if I see a part of an expression that needs to be simplified that has one of the trig functions squared, I can replace that with one of the trig identities. So here's the first thing that I would think to myself, and I'm going to kind of write this over to the side. I know that sine squared of x plus cosine squared of x is equal to 1, and therefore I can rewrite this as sine squared of x equals 1 minus cosine squared of x. So anywhere that I have sine squared, I can replace it with 1 minus cosine squared. And that's what I'm going to do in this problem. I'm going to take that sine squared, and instead I'm going to write cosine squared as the numerator. I'm going to write 1 minus cosine squared as the numerator of that fraction. Now, you cannot cancel anything from the numerator or the denominator of this fraction yet, because they're subtraction problems. You can only cancel from a numerator to a denominator if everything's being multiplied. But I should notice that the numerator is now a binomial, that the first term and the second term are both perfect squares. 1 is a perfect square, and cosine squared is a perfect square. So I can rewrite the numerator of that binomial as 1 plus cosine of x times 1 minus cosine of x all over 1 minus cosine of x. Now, the entire denominator can cancel with this factor that's being multiplied in the numerator, and my final answer for this problem is going to be 1 plus cosine of x. The next type of skill that you might want to try for simplifying trig identities is when you have fractions that you would use a common denominator to add or subtract. So, for example, in this problem, I have a fraction and I'm adding a number that's not a fraction. But if I think about this as cosine of beta over 1, then I can multiply both fractions by cosine over cosine in order to have common denominators. So the thinking here, sine squared of beta over cosine of beta plus cosine of beta over 1, and then I'm going to multiply this by cosine of beta And if I do that in the denominator, I also have to do that in the numerator. And when I do that, now I'm going to have sine squared of beta plus cosine squared of beta all over cosine of beta. Now, notice that your numerator is equal to 1. Sine squared plus cosine squared equals 1. And so that whole entire fraction just equals 1 over cosine of beta. And 1 over cosine is always equal to secant. So secant of beta is my final answer. So those of you who have been skeptical about using a separate sheet of paper, this might be the time. So for part B, we're going to have a lot of steps. So you might want to grab your separate sheet of paper at this point. I'm going to see if I can squeeze it onto the screen here. So notice that the one fraction has a denominator of cosine, and the other fraction has a denominator of 1 plus sine of x, and they're not common denominators, so I need to do some multiplying to get common denominators. So I'm going to multiply the first fraction by 1 plus sine of x over 1 plus sine of x. And I'm going to multiply the other fraction by cosine of x over cosine of x. Now I'm going to write out the whole numerator without distributing first, just to see how it lays itself out. And so that's going to be sine of x times 1 plus sine of x plus, and then in the second fraction I multiplied cosine times cosine, and so that'll be cosine squared of x. And my common denominator in this fraction is cosine of x times 1 plus sine of x. Now, my next step, I'm only going to distribute in the numerator, and that's the only change I'm going to make here. So now I'll have sine of x times 1 is sine of x. Sine of x times sine of x is sine squared of x. And bring down the cosine squared of x. All of that over cosine of x times 1 plus sine of x. Now, make sure that you track with all of those steps. And the next thing that I want you to notice is that, hang on a second, the sine squared of x plus the cosine squared of x in your numerator can be replaced with a 1. Because of your trig identity, sine squared plus cosine squared equals 1, anytime you have a sine squared and a plus cosine squared in the same expression, you can change that to 1. So I'm going to rewrite that whole numerator as sine of x plus 1 over cosine of x times 1 plus sine of x. Notice now that the whole numerator can cancel with one of the factors in the denominator, and that whole entire thing becomes just 1 over cosine of x. and that gives you secant of x. I know you can't zoom in and out of your paper, so you may have needed a separate sheet of paper. For part C, it looks a little weird because this is the section that says find common denominators, but we don't have any denominators. So let's rewrite this as fractions. Remember that both tangent and cotangent can be written as quotients, where tangent is sine over cosine, and cotangent is cosine over sine. Now, I want common denominators, and so I'm going to multiply the first fraction by sine of theta over sine of theta. I'm going to multiply the second fraction times cosine of theta over cosine of theta. And now I have sine squared of theta in the first numerator and cosine squared of theta in the second numerator, and my common denominator is sine times cos. And I want you to think back to what we did in the previous problem. Anytime you have a sine squared plus a cosine squared in the same expression, you can automatically change that to 1. And so this becomes 1 over sine times cos. Now my thinking here, and you don't have to write this next step, but this is what's going on in my thought process, is that I've got 1 over sine of theta times 1 over cosine of theta. And we know that 1 over sine is cosecant of theta, and 1 over cosine is secant of theta. And with that, I have no denominators, parentheses, or addition or subtraction signs, and so I'm finished. So again, in letter D, we have a problem where there is no denominator, but I have clearly said that these problems in this section will have denominators that you need to change to common denominators. It also doesn't have any sines or cosines, and so if I start changing some things to sine and cosines, I'll have some denominators to play around with. So I'm going to start with the cosecant, and I'm going to write that as 1 over sine. And then I'm going to look at secant, which is 1 over cosine. And cotangent, last but not least, which is cosine over sine. Now, in order to have common denominators, I'm going to need for the second fraction, the cosine over sine, to have a cosine in the denominator as well. So I'm going to already multiply the numerator and the denominator by cosine of theta. And when I do that, my numerator becomes 1 minus cosine square root of theta, and the denominator is sine of theta times cosine of theta. And then you will notice that 1 minus cosine squared of theta is sine squared of theta, so I can change my whole numerator to sine squared of theta. Keep the denominator sine of theta times cosine of theta. Now the 1 sine in the numerator cancels with the sine in the denominator. And so that whole thing leaves me with, I still have a sine in the numerator and a cosine in the denominator, and that whole thing is equal to tangent of theta. Now, in in letter E, we're not going to be finding a common denominator. We're going to actually work that process backwards. So imagine that you already found common denominators for a subtraction problem and you did the subtraction. The original problem could be secant of x over secant of x minus cosine of x over secant of x. So what I'm saying here is that if you imagine this first term in the top over secant minus the second term in the top over secant, you can write both of those terms over secant and in that way kind of separate the fractions. And when you've done that, the first fraction is obviously equal to 1. So I'm going to rewrite that as 1. And in the second fraction, I'm going to change secant of x to 1 over cosine of x. And so this whole fraction becomes cosine of x over 1 over cosine of x. Now, this cosine of x over 1 over cosine of x, if you multiply by the reciprocal, you end up with cosine over cosine. And so you end up with 1 minus cosine squared of x. And 1 minus cosine squared of x is sine squared of x. If you followed all of that, then go ahead and fast forward a tiny bit to the next problem. But I want to take a little bit of time and talk a little bit more about what I did right here in changing cosine of x over 1 over cosine of x. I'm going to walk through that division to make sure that we're all tracking. So really, cosine of x over 1 over cos of x is the same thing as cosine of x divided by 1 over cosine of x. And remember that you write a division of fractions problem as a multiplication problem, but flip the second fraction. Well, I don't really need that 1 right there. Okay, and so that whole thing just becomes cosine times cosine, and that's cosine squared of x. And so I can replace this part of the problem with just cosine squared of x. Last but not least, letter F. This is another problem that I think you might need a separate piece of paper to write out because it might take you more space than what's in the box. And again, this is a problem that there are several ways that you could work through. You might start by foiling it. I'm going to start by changing the secant of theta to 1 over cosine of theta. And so I'm going to rewrite this whole thing. It's going to get ugly. But 1 minus cosine of theta times 1 plus 1 over cosine of theta. Now, I'm going to change the 1 right here. I'm going to change that to cosine over cosine so that I have common denominators. So I'm going to keep the first binomial, 1 minus cosine of theta, but the next one I'm going to change to cosine of theta over cosine of theta plus 1 over cosine of theta. And so I just changed the 1 to cosine over cosine. Now, again, I'm not yet ready to do anything with that first binomial. But in the second binomial, now I have cosine of theta plus 1 over just cosine of theta. And the next thing that I want you to think about, if you write the first entire binomial over 1, and then look at the two numerators, 1 minus cosine times cosine plus 1, and let me kind of, if you don't see it, I want you to kind of walk it through over here. 1 minus cosine of theta times cosine of theta plus 1. I'm going to rewrite that as 1 minus cosine of theta times 1 plus cosine of theta. And if you FOIL that, remember that that's the type of problem that's going to give you the plus cosine and minus cosine that'll cancel. And so your answer is going to be 1 squared, which is 1, minus cosine squared of theta. So take a minute and make sure that you understand where all of that comes from. And then when you're multiplying fractions, multiply the numerators. Well, we said that this numerator is 1 minus cosine squared of theta. Multiply the denominators. Well, that's 1 times cosine of theta, and that's just cosine of theta. Now I'm going to change the numerator, as we've done in several problems. I notice that 1 minus cosine squared is sine squared of theta over cosine of theta. And I find myself thinking, well, wouldn't it be nice if that were just sine over cos, because then I could have a tangent? Well, let's rewrite this, and instead of sine squared, let's make this sine times sine. So I'm going to write my numerator as sine of theta times sine of theta all over cosine of theta. And now I can think of sine of theta over cosine of theta as tangent, and that whole thing becomes tangent of theta, that's the green, times sine of theta, because you're thinking sine of theta over 1, and that's my final answer. So now on this last page, as I was working through these problems, I noticed that letter A is already a problem on one of the other pages. In fact, to be exact, it is the same exact problem as number 5C on the second page. Why did I do that? I don't know, and I can't believe I didn't catch it. But anyway, if you want to try letter A and not look back at 5C until you've finished it and just make sure you know how to do it, you can do that, or you can just fast forward a little bit. The next issue is that problem B, I must have copied wrong from wherever I took it because it can't be simplified. I have absolutely no idea what that problem should have been, but don't try problem B because there's nothing that you can do to simplify that problem. So we're going to move along and start with problem C on this last page. So sorry about that. Now, some of these problems require a little bit of creativity. When I look at this problem, what I see is that I've got secant and tangent and find myself thinking, well, I know, I'm going to kind of make a note of this off to the side, I know that tangent squared plus 1 equals secant squared, and that if I even wanted to rearrange it, that's 1 equals secant squared of x minus tangent squared of x. But in letter C here, neither of them are squared. It's secant, not secant squared. It's tangent, not tangent squared. And there's a plus sign there, not a minus sign there. Wouldn't it be nice if it were squared and minus? Well, I can manipulate this problem here by multiplying by the quantity secant of x minus tangent of x because if I FOIL the denominator, if I multiply secant of x plus tangent of x times secant of x minus tangent of x, in fact, I'm going to write out that multiplication over here. Secant of x plus tangent of x times secant of x minus tangent of x. So to FOIL, I want to multiply my firsts. That's secant times secant, so secant squared. My outsides, well, that's negative tangent times secant, so that's negative tangent secant. And then my insides, which is positive tangent times secant, which is positive tangent x secant of x. And then the lasts, which is tangent of x times negative tangent of x, is going to be minus tangent squared of x. Do you notice that this term and this term, negative tan secant, positive tan secant, are going to cancel? And that whole thing becomes secant squared of x minus tangent squared of x. So I'm going to go back up here and replace that denominator with secant squared minus tangent squared. So my numerator is 4 times secant of x minus tangent of x. And my denominator is what I just computed. So secant squared of x minus tangent squared of x. Now, remember over here that secant squared of x minus tangent squared of x is equal to 1. So I can rewrite that whole denominator as 1 4 times secant of x minus tangent of x all over 1. That entire fraction can be simplified to 4 times secant of x minus 4 times tangent of x. Why is the 4 there? I don't know. Somebody else gave me this problem. It would work great without the 4. But make sure that you understand the changes to the denominator and how we manipulated the problem so that the denominator would become 1. Problem D. I would start this problem by getting common denominators here. And so I would multiply this first fraction by cosine of x over cosine of x. And I would multiply the second fraction by 1 plus sine of x over 1 plus sine of x. And so what I get in my numerator, it's going to get ugly before it gets prettier, but what I get in my numerator is cosine squared of x plus the quantity 1 plus sine of x squared all over cosine of x times 1 plus sine of x. Now, take a minute and see if you understand what I mean when I say that you want to FOIL 1 plus sine of x times 1 plus sine of x. So if you know what I'm talking about, snatch a little space on the side of the page and write that out, or watch me write it out over here. So I'm going to FOIL 1 plus sine of x squared is the same as 1 plus sine of x times 1 plus sine of x. You actually have to FOIL that out because there's 3 terms in your answer. Be careful, because the mistake that some students would make is to write 1 plus sine squared and move on. But if you FOIL this, 1 times 1 is 1, 1 times sine of x is sine of x, 1 plus sine of x is sine of x. That's your outsiders and your insiders, right? Your outsiders is 1 times sine of x, and your insiders is 1 times sine of x. And then plus sine squared of x. And then when you combine your two like terms, you're going to get 2 sine of x. So your answer to FOILing is 1 plus 2 sine of x plus sine squared of x. And so back here in my big fraction, I'm going to replace everything I highlighted in yellow there with that expression. So this then becomes cosine squared of x plus 1 plus 2 sine of x plus sine squared of x, and all of that is over cosine of x times 1 plus sine of x. Now, you should have little alarm bells going off in your head right now, because you see an expression in the numerator that's all adding, and notice that you've got a cosine squared and a sine squared, and they're both being added. And your thinking process, you don't have to write this next step, but your thinking process could be that you move that sine squared to the beginning so you can rearrange the order of the terms you can be thinking sine squared of x plus cosine squared of x plus 1 plus 2 sine of x all over cosine of x times 1 plus sine of x. But really what you have here then is sine squared plus cosine squared. And that entire thing, sine squared plus cosine squared, is equal to 1. So now I've got 1 plus 1 plus 2 sine of x all over cosine of x times 1 plus sine of x. Well, 1 plus 1 here is 2, so that whole thing gives me 2 plus 2 sine of x over cosine of x times 1 plus sine of x. And if you look closely at the numerator, you can factor out a GCF of 2, and so that becomes 2 times 1 plus sine of x over cosine of x times 1 plus sine of x. Take a look at that. You should notice that 1 plus sine of x and 1 plus sine of x cancel. So when you do that canceling, you end up with just 2 over cosine of x. Now think about that. 2 over cosine of x is the same as 2 times 1 over cosine of x. You don't have to write that part if you can see it, because 1 over cosine of x is secant, and so my answer to this whole problem is 2 times the secant of x. Now in example E, again, you don't have common denominators, and you want common denominators. So I'm going to multiply the first fraction by secant of x minus 1 over secant of x minus 1. And I'm going to multiply the second fraction by secant of x plus 1 over secant of x plus 1. And you may be tempted not to write the numerator with parentheses, but track with me here. Start by writing the numerator with parentheses. You are subtracting this minus this. And write that out with the parentheses. So you have parentheses secant of x minus 1 minus parentheses secant of x plus 1. Then in the denominator, you've got secant of x minus 1 times secant of x plus 1. So let's look at two separate things. Let's start with the numerators. And remember that when you have a minus sign outside of parentheses, but there's no number, there's no coefficient in between, it's like distributing a negative 1. And you're going to negate both of the terms inside of that set of parentheses. And so my numerator now is going to be secant of x minus 1. The first one doesn't change at all. But then it's minus secant of x and minus 1. Now, in the denominator, let's work out this multiplication problem, and I'll come back and fill in where the question mark is for a minute. But I want to do that over here, so I'm going to FOIL, and I'm going to FOIL secant of x minus 1 times secant of x plus 1. And I hope that you're starting to see a pattern here when we're FOILing the trig functions. So here I have my firsts, so I have secant squared of x, and then my outsides, so secant of x times 1 is plus secant of x. Then my insides, which is this negative 1 times the secant of x, so that's minus secant of x. And then lasts, negative 1 times positive 1 is minus 1. Notice that you've got plus secant and minus secant inside the parentheses, or inside. Your two middle terms are like terms, and one's plus and one's minus, so they'll cancel each other out. And so when you FOIL that, your final answer here is secant squared of x minus 1. And so I'm going to put that where that question mark is in the denominator over here. And so that's going to be secant squared of x minus 1. Now, we still also have to simplify the numerator, and in the numerator, notice that you've got a positive secant of x and minus secant of x, and so those two terms are going to cancel each other out. But you've also got negative 1 and negative 1, and so that leaves your numerator as just negative 2 all over secant squared of x minus 1. Now, when you see this denominator, secant squared of x minus 1, you should recognize that that's equal to tangent squared of x. So now I have negative 2 over tangent squared of x. And all of that is going to give me negative 2 times cotangent squared of x. Cotangent because it's the reciprocal of tangent. In a simplified expression, we don't want to have a denominator. Now in letter F, I'm going to start a similar way. In fact, this might be one of those problems where you might want to pause the video and try the problem yourself first, and then check your answer. But I'm going to start by getting common denominators. So I want to multiply the first fraction by 1 plus sine of x over 1 plus sine of x. And I'm going to multiply the second fraction by 1 minus sine of x over 1 minus sine of x. And so my numerator is going to be 1 plus sine of x plus 1 minus sine of x. All over 1 plus sine of x times 1 minus sine of x. In this case, I don't have any negatives to distribute, so I can just drop the parentheses. Unlike the last problem that started as a subtraction problem and you have to track your negative signs. Also, when you FOIL the denominator, you'll get 1 minus sine squared of x. So maybe stop the video and double check that you understand how I got from the 1 plus sine times 1 minus sine to get 1 minus sine squared. Now, notice that your plus sine of x and minus sine of x are going to cancel each other out. And so your numerator becomes just 2 over 1 minus sine squared of x. And then 1 minus sine squared of x is cosine squared of x. And remember that you don't want a denominator in a simplified expression. And so this is going to be 2 times secant squared of x. Now, these last two problems have a little bit of a twist. And so let's take a look at letter G. And the first thing that you should notice is that you've got sine of a negative angle. So on your pink formula sheet, find where it says the negative angle identities, and notice that for sine of a negative angle, that's equivalent to negative sine of the positive angle. So I'm going to start by writing this problem again, but replacing sine of negative x with negative sine of x. So I'll leave the cosecant squared of x minus cotangent squared of x all over now negative sine of x, and then times that cotangent of x. And the negative sine of x replaced the sine of negative x. Now, I'm going to look at the numerator first, and I see cosecant squared and I see cotangent squared. And so here's my thinking. I see on the Pythagorean identities that cotangent squared of x plus 1 equals cosecant squared of x. And if I subtract cotangent squared from both sides, I can rearrange this to say 1 equals cosecant squared of x minus cotangent squared of x. Therefore, I can replace that entire numerator there with just a 1 over negative sine of x. And I'm also going to replace here this cotangent in the denominator with cosine over sine with the quotient identity, because I notice that the signs will then cancel. So now that I've done that, sine of x here and sine of x here cancel, and that entire fraction then becomes 1 over negative cosine of x, and all of that equals negative secant of x. And last but not least, in part H, your eye should immediately go to this thing, this crazy looking parentheses, that really means 90 minus x. And if you're thinking 90 minus x, remember that that has to do with complementary angles. Because if I have an angle x and I subtract it from 90, then it's going to give me the complementary angle. So on your formula sheet, if you notice where it says cofunction identities, you'll see that the sine of the complementary angle is equal to the cosine of the original angle. So I'm going to rewrite this entire expression with cosine of x replacing that sine of pi over 2 minus x. So I have sine squared of x times cosine of x minus cosine of x. Notice that you have a GCF, and so I'm going to take out the cosine of x and that sine squared of x minus 1. And that's where it gets a little tricky, because I know that I have a trig identity that has a cosine squared and a sine squared and a 1, but somehow the signs don't match up. So let's take a look at just the part in the parentheses here. And I'm going to think this off to the side. My thinking is that I know that sine squared of x plus cosine squared of x is equal to 1. And if I want sine squared minus 1, if I want sine squared minus 1, I end up with the subtraction reverse of what I want, because I would subtract sine squared from both sides. And remember that we can't switch a subtraction without making another change. So in order to switch 1 minus sine squared and to make it sine squared minus 1, I have to multiply both sides of the equation by a negative 1. And so the sine squared of x minus 1 is equal to negative cosine squared of x. So when I replace this identity in the parentheses over here, I'm going to replace it with negative cosine squared, not just cosine squared. So I have cosine of x times negative cosine squared of x. And my answer is going to be negative cosine to the third power of x.